Hello everyone, welcome back to my YouTube channel. In this video, I want to explain how to solve EJU Mathematics 2019 first section, course 1, number 3, which is the first question from part 2. You can check link on the description box below if you want to watch the solution for the other problem on this paper, or you can check my EJU playlist for another paper. Okay? In this question, we have a equals to square root of 5 plus square root of 3, and b is equals to square root of 5 minus square root of 3. We are to find the integers x satisfying this inequality. So this is our objective or our goal of this question. We want to find the integers x which is satisfying the inequalities below. Okay, first of all, we see that a over b is equals to blah blah blah. So first thing first, I want to find a over b. We already know a, which is square root of 5 plus square root of 3, and then b, which is square root of 5 minus square root of 3. Then, if you want to find a over b, just rationalizing the denominator. Square root of 5 plus square root of 3 over square root of 5 minus square root of 3. By rationalizing the denominator, of course, if we want to rationalize the denominator, we have to multiply both numerator and denominator with the conjugate of denominator, which is square root of 5 plus square root of 3 over square root of 5 plus square root of 3. And then by expanding the numerator and denominator, I think we will get a, b, and c here. For the numerator, I got 5 plus 2 square root of 15 plus 3. This is a plus b times a plus b. A plus b square is equals to a square plus 2ab plus b square. Then I got this expression. And then for the denominator, I have a minus b times a plus b. If you expand this, you will obtain a square minus b square. Then for the denominator, I got square root of 5 square, which is 5, minus square root of 3 square, which is 3. And then if we simplify this expression, 5 plus 3 is equals to 8 plus 2 square root of 15 over 5 minus 3 is equals to 2. Of course, we can divide all the terms by 2. So I will get 4 plus square root of 15. This is my a, b, and c. So a is equals to 4, b and c is equals to 1 and 5 or 15. Hence, the largest integer less than a over b is equals to d. Now we want to find the largest integer, which is less than a over b. If you see our a over b, if you see our a over b, we have 4 plus square root of 15. Square root of 15 is approximately equals to 3.9 if I'm not mistaken, because square root of 16 is 4, then square root of 15 I think around 3.9. So for our a over b, I have 4 plus 3 over 9, which is approximately is equals to 7.9. So the largest integer which is less than 7.9 is, you know the answer I think. The answer is 7. The largest integer which less than 7.9 is 7. So I think for D, my answer is 7. Next, For F and H, in the following sentence, choose the correct answer from choices 0 until 7. And then for E and G, enter the correct numbers. So remember, for F and H, we have to choose the correct answer. But for E and G, we have to write down the correct numbers. The question is, when x is an integer, the left side of the inequality can be expressed without using the absolute value symbol as follows. So the idea is how we eliminate or how we change the expression of this absolute becomes no absolute value symbol. So I do not want this expression has an absolute symbol. The concept of absolute is if I have absolute x, let's say if I have absolute x minus f, x minus, let's say x minus a, it's gonna be equal to x minus a if x is greater than a, or it's gonna be negative x minus a if x less than a. This is the basic concept of absolute function. So if we want to eliminate or to erase or to get rid the modulus or absolute function here, we can use this concept. So for our inequality, we have absolute x minus a over b. By using the same concept here, I will have absolute x minus a over b is equals to x minus a over b if x greater than a over b, and then it becomes negative, open bracket, x minus a, negative x minus a over b if x less than a over b. We already know that a over b is around 7.9. So my a over b here is around 7.9. 7.9, this is also 7.9. So if you see from this equation, if x less than or equals to e here is an integer. If you see the inequalities, we have less than or equals to, so refer to this part. If x less than or equals to an integer, then I think e is 7. Because x less than 7.9, if we want to write down the integer which is less than 7.9, then my answer is 7. So I think e is 7. And then for g, if x greater than or equals to an integer, since the inequality here is greater than or equals to, so you can refer on this part. X greater than 7.9. So if I want to write down an integer which is greater than 7.9, then I think g is equals to 8. So e is 7 and g equals to 8. And then for the first one, if x less than 7, less than or equals to 7, refer to this one, then 2 times absolute x minus a over b plus x is equals to blah blah blah. Remember, we refer to this one. So the absolute symbol can be changed into this one. We do not need the absolute anymore. So for this one, I have 2 times this one. If I distribute the negative sign, I got negative x plus a over b. Negative x plus a over b plus x. And then if we simplify this expression, I will get negative 2x plus 2 times a over b plus x. Negative 2x plus x, we got negative x plus 2 times a over b. If we want to express in exact form, then a over b can be substituted by 4 plus square root of 15. 4 plus square root of 15. And then if you expand or distribute 2 here, you will get negative x plus 8 plus 2 square root of 15. This is for f. If you see from the option below, then I think for f the correct answer is number 2. Negative x plus 8 plus 2 square root of 5. And then same thing for the second part. If x is greater than 8, so refer to the first part here, x greater than or equals to 8, so you refer to this one. Then this absolute symbol or absolute function can be changed into x minus a over b. So we get rid the modulus and it becomes x minus a over b plus x. And then if you simplify it by distribute the 2 into the bracket, I will get 2x minus 2a over b plus x. 2x plus x, we got 3x minus 2 times, substitute a over b by 4 plus square root of 15. And then if you simplify this, it becomes, I write it down here, yeah. It becomes 3x minus 8 minus 2 square root of 15. So the correct answer for H among the choices 0 until 7 is number 5. 3x minus 8 minus 2 square root of 15. So H is number 5. Okay, for the last part on this question, does the integer x satisfying inequality blah 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 are those greater than or equals to I and less than or equals to j? So we want to find the integer that is satisfying this inequality, which is our objective or our goal. Since we already know that this expression can be changed into either f or h, so first of all, I will see x less than 7 first. So we divide it into 2 cases. The first one is for x less than or equals to 7. For the first case, this whole thing, which is the same as this, yeah, can be substituted by negative x plus 8 plus 2 square root of 15 for the first case. So this left hand side expression can be substituted by using negative x plus 8 plus 2 square root of 15. So for the first case, I got negative x plus 8 plus 2 square root of 15 less than 10. Of course, we can find the solution of this inequality. Just move all the number to the right hand side. I will get negative x is less than 10 minus 8 minus 2 square root of 15. Since we focus on the integers, then I can change square root of 15 around 3.9. Then negative x is less than 10 minus 8 times 2 times 3.9. If you calculate it, you will get 10 minus 8. 10 minus 8 is equals to 2. 2 minus 7.8, you get negative 5.8. So negative x is less than negative 5.8. If we divide the negative sign to the right hand side, then we will have x greater than. Remember, if you divide by negative value, we have to flip or to change the direction of inequality. Then x is greater than 5.8. Since we talk about integers x, then I can write down x greater than 5.8 as x greater than or equals to 6. So the solution for the first case is x less than 7 and x greater than 6, which is, my solution is greater than 6 but less than 7. So I got 6 less than or equals to x less than or equals to 7. This is the solution for the first case. Don't forget, we still have the second case. So this is not my final answer, because we have to consider both cases. So for the second case, for x greater than or equals to 8, x greater than or equals to 8, this expression can be changed or can be substituted by this. So for the second case, I get 3x minus 8 minus 2 square root of 5 is less than 10. If you move all the constant to the right hand side, you will get 3x less than 10 plus 8 is 18 plus 2 square root of 15. And then if I divide the 3 to the right hand side, I will get 18 divided by 3, we got 6 plus 2 square root of 15 divided by 3. Square root of 15 is around 3.9 divided by 3. 3.9 divided by 3, 1.3. 1.3 times 2 is 2.6. So x is less than 8.6. And then, once again, since x is an integer, then x less than 8.6 can be written as x less than or equals to 8. 8 is the smallest, x is the largest integer, which is less than 8.6. So x is less than or equals to 8. Then what is the solution for the first case? For the second case, we have x greater than or equals to 8 and x less than or equals to 8. Then the solution for the second case, for x an integer, is x equals to 8. Greater than or equals to 8, less than or equals to 8. The intersection is only x equals to 8. After we got two solutions for two or both cases, at the end we have to combine them. Combine mean union. So we have to union or combine them. If you imagine from the number line, 6 until 7 is here, and then 8. If x is an integer, then my final answer is 6 less than x less than 8. X is an integer. This is my final answer. So, the integer x satisfying this inequality are those greater than or equal to 6 and less than or equals to 8. So I is 6 and then j is 8. Okay, that's it for this video. Thank you for watching till the end. I hope I can see you guys on my next video. Thank you and bye-bye.